Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. So today we are solving paper 2-3 for May-June 2025. So let's start. But before we start, kindly like and subscribe the channel. And if you find anything helpful, kindly remember me in your prayers. Okay, so let's begin. Question number 1. Which quantity can be measured using a ruler? Okay, so the distance traveled by a toy train in 1 second. Okay, the temperature of the toy train, the time taken for a toy train to travel 1 meters, and the volume of a toy train. Okay, now if we see our options, so the toy train is somewhat an irregularly shaped object, so the volume can be measured using a cylinder. Okay, so the ruler is not going to be used. And the C option states that the time taken for a toy train, so the time can be measured using a stopwatch and not using a ruler. The temperature can be measured with a thermometer and not a ruler. So A, the distance traveled by a toy train in 1 second can be measured by the ruler. Okay. Question number 2. A car is driven from one town to another town along a road that is not straight. The driver of the car divides the total distance traveled by the total time taken. Which quantity does the driver calculate? Okay, if he has divided the total distance by total time, so that is the formula for speed. Speed is equal to distance over time. So he has measured the average speed of the car, not the acceleration, not the kinetic energy or the velocity of the car. Okay, because for example velocity जो है that is measured with a different formula. With acceleration in time, kinetic energy is half mv square, acceleration is vf minus vi over at. So they can't be measured with this formula. Only speed of the car can be calculated with this formula. Question number 3. Which quantity can be determined from the area under a speed time graph? Okay, we know that the area under speed time graph represents the distance covered. So B is going to be our correct answer. And the area under distance time graph gives us nothing. Okay, so B is the correct option. Question number 4. Students are asked for statement about weight of an object. 3 of the statements are listed. Number 1, the weight is the quantity of matter in the object. The weight is the effect of gravitational field on the object. The weight is the force of attraction between the object and the earth. So option A is not going to be correct, because the mass is the quantity of matter in the object. Number 2, the weight is the effect of gravitational field on the object. This is correct. And the weight is the force of attraction between the object and the earth. This is correct as well. So 2 and 3 are going to be correct and 1 is not going to be there. So any option that has 1 in it is not correct, and D is our correct option. Question number 5. Samples of 3 different liquids have equal masses. Okay, the volume of the samples are 190 centimeter cubes, 200 centimeter cubes and 235 centimeter cubes. The liquids are poured into large measuring cylinder and the liquids form 3 separate layers because they do not mix. Okay, what are the readings on the measuring cylinder at the 2 boundaries between the sample? Okay, in order to solve this thing, we need to deconstruct the question, okay, and understand what we are being told in the question. Now they've basically the thing is that there are volumes and there are masses, and then there are liquids that are not mixing up. So when the liquids are added to say a cylinder and they do not mix, then they form layers based on their densities. The less dense liquid is going to be on the top and the most dense being at the bottom. Okay, and the liquids have been told to us that they have equal masses. So whatever is happening is due to these volumes. Okay, so we know that density is related to mass and volume by this formula. And since masses are the same, so density over here is inversely proportional to volume. So lesser the volume, more the density, and more the volume, lesser the density, and vice versa. Okay? So this means that this liquid has the highest volume, so it will have the least density. Okay? And then this and then this. ठीक हो गया? So now, once we've established this fact, so we can just draw a measuring cylinder, okay? And we know that this has the least volume, so this will have the most density, okay? So this is going to be the most dense liquid, okay? So if we have 100, 200, 300, 400, 500, 600, these marking on the measuring cylinder. So 190 is going to be occupied with this liquid almost up till here. Okay, so this is this liquid, and the next is going to be the liquid which is in the middle, 200 centimeter cubes. So this is going to be next because this is after this, and 200 centimeter cube volume more dense the liquid is than 235 centimeter cube. So what we have here is that 100 and almost around here is going to be the boundary for the second liquid. Let's change the color. Okay, so this is going to be 200 centimeter cubes, and then 235 centimeter cubes is going to be on the top because it has the most volume. So now this is 190 centimeter cube. Lesser the volume, more the density. So this was the most dense liquid, and then came this liquid, and then at 235 centimeter cubes is the third liquid, which was the least dense because it had the most volume. So 200 and around over here, it's going to be roughly around here. It's going to be the third liquid. Okay, so it's here. So once we've drawn this, so now we are going to go to a question. What are the readings on the measuring cylinder at the two boundaries between the sample? So the first boundary is at 190. Okay, so this is the first liquid and this is the second liquid. So this is our first boundary. So it is at almost 190 centimeter cubes. Okay. And a second boundary is somewhere around 390 or something, because 190 was here and just drew it just below 400. So this is going to be 390, right? Just below 400. So our boundary, first boundary is going to be at 190 centimeter cube, and the next boundary is going to be at 390 centimeters cube. So this is our answer. Once you've understood this thing, so you can answer it pretty well. I've just explained the whole fact so that you know what we were doing. Okay, question number 6. A car moves along a level road. The diagram shows all of the horizontal forces acting on the car. Which statement is correct? The car is slowing down, the car is speeding up, the car is moving at a constant speed, and the car is moving backwards. Okay, now let's look at the forces. So the forward force over here is 2000 newtons, and the backward force over here is 800 plus 500. So this gives us an answer of 1500 newtons. So forward force is 2000 newtons and backward force is 1300 newtons. So basically the backward force is smaller than the forward force, so the car is going to be moving forward. Okay, the car is not going to slow down. If the car was slowing down, the backward force had to be greater than the forward force, so it is not slowing down. The car is speeding up. Yes, it is speeding up because the forward force is more than the backward force. Okay, the car is moving at a constant speed. No, for the car to move at a constant speed, the forward forces should be balanced by the backward forces, and they are not being balanced. The forward force is more than the backward force, and the car is moving backwards. So if the car was moving backwards, then this force wouldn't have been greater. So D is also not correct. Forward force is more, so it is moving in this direction and not in the backward direction. Okay? So B is the correct answer. Moving on to question number 7. A car is traveling around a circular track at a constant speed as shown. In which direction is the resultant force of the car? We know that when anything is moving in a circle, the resultant force is directed towards the center of that circle. So B is going to be our correct option for that. Okay, so this is a rule for centripetal forces. Question number 8. A railway truck of mass 800 kgs moves with a velocity of 1 meter per second to the right. It collides with a railway truck of mass 12,000 kgs moving at 2 meters per second to the left. Okay, the two trucks become joined to each other when they collide and move off together. What is the velocity of the two trucks after the collision? Okay, now let's deconstruct the statement. So there is one truck that has a mass of 8,000 kgs and it is moving in the right direction, and then there is another truck that has a mass of 12,000 kgs and it is moving in this direction, and this is moving with a speed of 1 meter per second and this is moving with a speed of 2 meter per second, and they are in the opposite direction. So we have to find the velocity of the two trucks after the collision, and whenever the things are colliding and there is mass and there is velocity, we know that it is a question related to momentum. Okay, so we have a formula for that. Mass of the first object, let's call this the first object and let's call it the second object. Okay, mass of the first object and the velocity of the first object plus mass of the second object and its initial velocity is going to be equal to mass of the first object and the final velocity of that object and mass of the second object and final velocity of that object. Okay, this is the law of conservation of momentum. Before the momentum before collision and after collision is conserved. Okay, acha. One more thing that we have to keep in mind is that both of these objects or trucks are moving in opposite direction. Momentum is a vector quantity and has both direction as well as magnitude. So we have to keep in mind the fact that since both of them were moving in the opposite direction, so the velocity of one of these trucks has to be positive and one of these has to be negative. It is up to you that you take the velocity of the first truck to be positive or that of the second truck to be positive. One of them has to be negative. So let's take the velocity of this truck to be positive and velocity of this truck to be negative, just to make sure that we have cleared the fact that they are moving in the opposite direction. Okay, so we are now going to write in the values. So the first truck has a mass of 8,000 kgs and a velocity of 1 meter per second, and the other truck has a weight of 12,000 kgs and a velocity of -2. Okay, and then we know that the mass of the first truck is 8,000 and velocity we don't know, and the mass of the other truck is 12,000, and the velocity we have to find. And they've told us that when they collide, they move off together. So the velocity for both the trucks are going to be same since they are joined to one another. Okay? So what we can do is 8,000 plus minus 24,000 is equal to, we can take V2 as common and add 8,000 plus 12,000. Okay? So the answers that we get are minus 16,000 and adding these is going to give us 20,000. So minus 1600 over 20,000 is going to give us the velocity, the final velocity of these two objects, and it is going to be 0.8. Okay? And it's going to be minus 0.8 meter per second. So the velocity that was negative was the second object, and as the mass of the second object was greater than the mass of the first object, so they are going to move in this direction afterwards. So ye to the left. ठीक हो गया? So 0.80 meter per second to the left, and this is how we've done this and solved this question. Okay. Moving on to question number 9. A stone is dropped from a bridge which is 22 meters above a river. What is the speed of the stone when it hits the water? Okay. To find the speed, we have a formula. Speed is equal to distance over time. Okay. So we have been given the distance, but we don't know the time, and we can't find the time as well. So this means that this formula is not going to be used over here. And we can see from the question that a stone was dropped from the bridge. So when the stone was taken to the top of the bridge, so it must have gained gravitational potential energy because it worked itself against the gravitational field. And then when it was dropped, so it must have gained kinetic energy, and we know that the energy is neither created nor destroyed according to the law of conservation of energy. One form of energy is converted into another form. So what we do is we equate gravitational potential energy and kinetic energy. The formula for gravitational potential energy is mgh, where m is the mass, g is the gravitational force, and h is the height, and that for kinetic energy is half mv square. And now in the question we don't have any mass, and masses are on both sides, so we are going to cancel them. So over here we have g. We can put the value of g to be 9.8, and height is given to us in the form of 22 meters, and this is going to give us the value of the velocity or the speed of the stone. So when we solve all of this, we have an answer of 5.6, and then obviously we have to take this 2 to the other side. So 2 into 215.6 is going to give us v square. So this is going to give us 430. V square is equal to 431.2, and since we just need velocity and not velocity square, so putting square root on both sides to get rid of this square, so v is going to give us an answer of 20.76. So it is going to be 21 meter per second. This can be rounded off to 21 meter per second. Okay, so B is our correct option. Okay. Okay, moving on to question number 10. Which row describes the particle structure of a gas? Okay. Distance between the particles. Obviously, the distance between the particles of the gas is much greater than that of solids or liquids. So the distance between the particles, we know that is going to be far apart. And the motion of the particles, the motion of the particles is going to be random. Vibration is for solids. Okay. So D is going to be our correct option for that, as gases, the molecules are far apart and they move in a random pattern. Okay. Moving on to question number 11. The particles of a gas in the container of fixed volume gain energy in the kinetic store. Okay. Which effect does this have on the gas? Okay. Now, if the kinetic energy is increased, there must be an increase in the temperature. And when the kinetic energy is increased, the gas molecules are going to apply more force on the walls of the container, as their momentum is going to change. Okay, so this much we know when they've given us that the container has a fixed volume and it has gained energy in the kinetic store. So kinetic store ko energy tabhi increase hogi when the temperature has been increased. So these two things are going to happen. Now let's look at the options and see what fits with our description. Achha, both the pressure and the temperature of the gas increases. Yes, the pressure increases because the momentum has increased, the force has increased. Know that pressure is equal to force over area. ठीक है, so the force is increased, so the pressure is going to increase as well, and the area is being kept constant, so this is not going to get into the way. So yes, this seems to be a good option, but let's go through the other option. Only the temperature of the gas increases? No, if the temperature has increased, so it will increase the pressure. ठीक है, so this is not correct. Neither the pressure nor the temperature, nahi, both of them are going to increase. Only the pressure of the gas increases. The pressure has increased because of the increase of temperature. So this is also not correct. So A is going to be our correct option for this question. Okay. Question number 12. Gas particles exert pressure when they collide with the walls of the container. Which statement about the gas particles is correct? They experience a change in force which results in a pressure equal to momentum into area. No, in this case, force is equal to change in momentum over time taken. So this is the wrong formula. They experience a change in force which results in the pressure equal to momentum over area. The pressure is equal to force over area. It's not equal to momentum over area. They experience a change in momentum which results in the pressure equal to force into area. Nahin, force over area is going to be the formula. D, they experience a change in momentum which results in the pressure equal to force over area. Yes, this is the correct formula. So D is going to be our correct answer. Question number 13. A solid changes into liquid. Which term describes this change in state? When a solid changes into liquid, it is obviously melting. So easy question. D is the correct answer. Okay, question number 14. The diagram shows some of the apparatus used to determine the specific heat capacity of a metal block. Which additional pieces of apparatus are required to find the specific heat capacity? Okay, if we have to find the specific heat capacity, we have the formula Cm delta T. So C delta E by M delta T, where M is the mass, delta T is the temperature, and energy obviously is going to be calculated as well. So we have an ammeter and we have a thermometer to measure the temperature. So we need something to measure the mass of the block. So we are going to need a balance. So let's look at the options: stopwatch, voltmeter, and a balance. Stopwatch, okay, voltmeter, balance is correct, so this we can keep in mind. Resistor, stopwatch, and ruler, nahin. The balance has to be there because the mass has to be calculated using the balance. Ruler, balance, and force meter. Balance is correct, but specific heat capacity mein there is nothing there for a ruler to measure. No distance is being measured, no length is being measured. So ruler is not going to be required, and balance is going to be required, and force meter is also not going to be required because weight is not being mentioned, not being measured over here. Voltmeter, thermistor, and insulation. This is also not correct because we need something to measure the weight, mass of the object. So voltmeter can measure the voltage, and stopwatch can measure the time, and balance is going to give us the mass. So A is going to be the correct option. As energy can be P into T as well, power into time. The power can be calculated with voltmeter and time can be calculated by stopwatch. So all of these are going to be required and other things are not going to be required. So A is our correct option. Question number 15. Four different surfaces are at the same high temperature. Okay. Which surface emits thermal radiation at the slowest rate? Okay. When the surface is black and the surface is dull, so this is going to radiate at the highest rate. Okay. And you can and surface area also matters. Greater the surface area, greater the rate of radiation. So this cannot be it, because the color of the surface is black and the texture is dull. Although the surface area is lower, but this can't be at a slower rate, and this has a surface area of 100 centimeter cube, so this is also not going to be our answer. Now, white substances emit thermal radiation at a slower rate than black and dull surfaces, so this is going to be it. And also the surface area is lower as well, so C is going to be our correct option. White, shiny, and the option with the lowest surface area is going to emit thermal radiation at the slowest rate, so C is going to be our correct option. Moving forward to question number 16. An object has a constant temperature. Okay. Which statement is correct? There is no energy transfer to and from the object. The energy is being transferred even if it is at a constant temperature. The energy transferred is going to be the same at which the energy is being received. So option B, the rate at which the object receives energy is the same as the rate at which it transfers the energy away. Yes, B is the correct answer. The constant temperature means that the object is receiving energy at the same rate at which it is transferring it away. Okay, so this is the correct option. Let's go through C and D as well. The rate at which the object receives energy is smaller than the rate. No, smaller nahi hoga, it has to be the same, and greater bhi nahi hoga, it has to be the same. So B is our correct option. Question number 17. Which row correctly describes light waves? Okay, light waves are a type of transverse wave. All the ones in the EMS spectrum are transverse wave, and the direction of the vibration obviously has to be, for a transverse wave, it has to be perpendicular to the direction of the motion. So like this. So D is going to be our correct option for that. Question number 18. A narrow beam of light consists of two waves of different wavelengths. Okay, there are two waves of different wavelengths. The beam of light hits a sharp edge. What effect will be seen beyond the sharp edge? Okay, if there is an effect that is seen beyond the sharp edge, it has everything to do with diffraction. Okay, that is the bending of the light. Okay, when it reaches a corner. So we know that diffraction and wavelength are directly proportional to each other, in the sense that more the diffraction, more the wavelength, and vice versa, lesser the diffraction, lesser the wavelength. So the beam that consists of two waves, the one with the greater wavelength is going to diffract more than the one with the lesser wavelength. Okay, so option A states that both waves continue along the straight line as before. No, this is not correct. Both waves bend sharply and continue along a new straight line. Okay, the wave of longer wavelength bends around the sharp edge more than the wave of the shorter wavelength. So this is exactly what I've stated over here, that the bending is due to diffraction, and diffraction is directly related to the wavelength. So more the wavelength, more is going to be diffraction, and C is going to be our correct option. On to question number 19. Sorry. An object is placed 30 centimeters in front of a plane mirror. Which statement describes the image of the object? Okay, A, the image is the same size as that of the object and 30 centimeters from the object. Okay, same size is correct, and we will see about 30 centimeters. The image is the same size as the object and 60 centimeters from the object. Okay, smaller and smaller, these are not applicable, because we know that whenever there is an image formed by a plane mirror, so it is going to be the same size as that of the object. It is going to be at the same distance as the object is from the mirror. It is going to be in the same line. It is going to be virtual, and it is going to be laterally inverted. So these are the properties related to the images formed by the plane mirror. So now what they've told us, that if this is the mirror, the object is placed 30 centimeters, this is the object, away from the mirror. So the image that is going to be formed is also going to be 30 centimeters behind the mirror. Okay? It has to be at the same distance as that was, the image has to be at the same distance from the mirror as was the object from the mirror. And now they've asked us that the image is of the same size as the object in 30 centimeters from the object. So it is going to be 30 centimeters from the mirror on either side, but if you take the distance of the object from the distance of the image from the object, so it is going to be 30 plus 30, that is 60 centimeters, right? They are not asking or telling us about the distance of the image from the mirror. They're asking us about the distance of the image from the object. So this is that distance. So 30 plus 30 is going to be 60 centimeters. So B is going to be our correct option. The image is going to be the same size as the object and 60 centimeters from the object. Okay? From the mirror, it is going to be 30 centimeters, like the object was from the mirror. But when they're asking about the distance of the image from the object, so obviously it's going to be 30 plus 30 is equal to 60. Okay? I hope you understood the concept. Moving on to question number 20. Which statement about total internal reflection at glass air boundary is correct? Okay, for total internal reflection to occur, the first thing is that the light has to move from a more dense to less dense medium, and the angle of incidence has to be greater than the critical angle. Okay? So now let's look at the options. The angle of incidence inside the glass must be equal to the critical angle. No, this is not correct, as I've just stated that the angle of incidence has to be greater than the critical angle. Okay? So this is not correct. The angle of incidence inside the glass must be less than the critical angle. Nahi ji, it should be greater than the critical angle. I've just stated that. The critical angle is proportional to the refractive index of the glass. Nahi ji, this is not correct. The speed of light in glass must be less than the speed of the light in air. Yes, this is true. This is due. This is the fact that refraction happens and then total internal reflection happens, because there is a difference in the speed of light of the glass and that of the air. This is the correct statement. All the other three are not correct. Moving on to question number 21. What is the speed of radio waves in vacuum, and what is the speed of gamma rays in a vacuum? So all the waves that are there in the EMS spectrum have a speed of 3 into 10 raised to the power 8 meter per second. So as radio waves and gamma rays both are a part of the EMS spectrum, so they both will have the speed of 3 into 10 raised to the power 8 meter per second in the vacuum. Okay, so C is going to be our correct option. Question number 22. A student makes sound in front of a large wall. She hears an echo at time t after making the sound. The speed of the sound in air is v. Which expression is used to calculate the distance between the student and the wall? So whenever there is an echo involved, so we have the formula speed is equal to 2d over t. The speed over here is given by v and 2 times distance over t. So the distance is going to be given with v into t over 2. So let's look at an option that gives us that. So this doesn't give us this doesn't give us this. V into t divided by 2. C gives us this option. So C is our correct option. Number 23. What is a compression? A point in a longitudinal wave where the particles of the medium are close together. Yes, this is correct. Compression is going to be in a longitudinal wave, not in a transverse wave, and this is an area where the particles are close together as opposed to rarefaction where the particles of the medium are far apart. Compression word states being compressed, being close together. So A is going to be our correct option. Question number 24. 24. Which row describes the magnetic field around a weak magnet? Direction of the field. The direction of the field around a weak magnet or a strong magnet would always be from North Pole to the South Pole. So these options will be eliminated. And spacing of field lines will be far apart. A weak magnet creates field lines which are far apart. The closer the field lines, the stronger the magnet. So B is our correct option. Question number 25. A 0.60 meter length of resistance wire with a diameter of 0.25 mm has a resistance of 6 ohms. A second piece of resistance wire of the same material with a diameter of 0.50 mm also has a resistance of 6 ohms. What is the length of the second piece of wire? Okay, whenever there is a wire with a length and an area or diameter and a resistance and it's being compared, so we always use the formula R1 A1 over L1, R2 A2 over L2. How we've reached this formula, you can always go to the topic of resistance where I've solved all the past paper questions till about 2014 that were in the IGCSE exam of all variants actually. So you can go and look at that topic and you'll see how we came across this formula and how easy it is to use this formula when the resistances of a wire with area and length are being compared. Okay, so let's begin. So the first wire has a resistance of 6 ohms, has a diameter of 0.25, and as we know that area is equal to diameter square. So if 0.25 is the diameter, so in order to make it area we need to square this, and length is 0.60. The resistance of the second wire is 6 ohms as well, and the diameter is being used again, so 0.50 square, and the length of the other wire is what we have to find. Okay, so after we solve all of this, so we will get the length to be 2.4 meters. Okay, so D is going to be our correct option. Okay, question number 26. A circuit contains a cell with an electromotive force of 2 volts. The current in the circuit is 2 amperes. How much energy is transferred by the cell in 2 minutes? Okay, if we are talking about energy, so we know that a formula that connects all of these entities together is energy is equal to VIT, where V is the voltage, I is the current, and T is the time. So voltage is 2 volts. The current is 2 amperes as well, and the time is 20 minutes. The time has to be in seconds, so we will multiply 20 with 60 to convert it into seconds. Okay, so after we calculate all of this, we get an answer of 480 joules. So this much is energy is transferred by the cell in 2 minutes. Okay, recommended is that you learn all these formulas. They are there in the Cambridge syllabus as well, and your teacher or your notes or your book, wherever you've studied from, also would have provided you with these formulas. And the topic of electromotive force and energy, I have given an intro of all these formulas that are going to be helpful to you and that you have to remember. So kindly go and refer to that video, and you'll learn many things in that video regarding these formulas and everything else. Question number 27. What is the electromotive force of a cell? Okay, EMF of a cell basically, as you can see that the formula for EMF is VI, that is a voltage into current. So it is basically the energy supplied per unit charge as the charge passes through the cell. So the charge that passes through the cell per unit time is not correct. It's the energy supplied per unit charge as the charge passes through the cell. So the energy supplied per unit charge is very important. So B is our correct answer. The total charge flowing through the cell, this is not EMF. Total energy stored in the cell is also not EMF. Okay, 28. 4 lamps and 4 switches are connected to a power supply as shown. When all switches are closed, all the lamps are lit. When one of the switches is then open, only one lamp goes out. Which switch is opened? Okay. Now, if we look at our circuit, so this switch needs to be closed. Okay? Because if this is positive and this is negative, so the current has to start from here and then this switch has to be closed as well. Even if this was positive and this is negative, so these two switches had to be closed in order to complete the circuit. Okay? Wherever your positive or negative is. So these two needs to be closed. And there is to be just one bulb that has to go out. So if the current moves here, then this is closed, then this lamp is also lit, this lamp is also lit, and the current can go here and complete the circuit, even if it doesn't go over here. So if switch C is open, all the other lamps are going to lit except for this one. So C is the switch, which is when opened, only one lamp goes out. Okay, so if we complete the circuit, so we can easily reach our answer. Question number 29. In which mains electric wires are the fuse and the switch placed? A fuse and the switch both have to be placed in the live wire, obviously. So fuse, earth and live. The purpose of the earth somewhat is to act like a fuse, to disconnect the electricity when there is more electricity than what is required. So no, earth wire doesn't contain fuse. Live wire contains the fuse and live wire contains the switch. Neutral is going to serve no purpose, obviously. So B is our correct answer. Question number 30. The diagram shows a wire moving downwards in a magnetic field between two magnetic poles. There is an induced current in the wire because of the movement. The induced current produces a force on the wire. In which direction is this force? Okay, whenever we talk about induced current, we know that we have to use our Fleming's right hand rule as opposed to using the Fleming's left hand rule. Okay, but if you look at the statement of the question, the movement of the wire is shown to be in the downward direction. So if the movement is in the downward direction, then the force is going to be opposite to that movement, so it is going to be in the upward direction. So we haven't been told about the direction of the induced current, and if we were told that, it would have been very easy to find the force with Fleming's right hand rule. But this thing also helps you out that if the movement of the wire is in the downward direction, the force is going to be in the upward direction, and if the movement of the wire was in the upward direction, the force would have been in the downward direction and vice versa. So just this thing brings us to the point that if the movement of the wire is in downward direction, the force is going to be in the upward direction. Okay, moving forward to question number 31. When the generator shown rotates, there is an AC electromotive force across the resistors between points P and Q. Diagram shows the position of the coil at time t is equal to 0. The coil rotates clockwise, okay, in this direction. At time t1, the coil is positioned horizontal as shown in diagram 2. So the graph shows the output EMF between points P and Q plotted against time. Which point shows the EMF at time t1? Okay, if this is time t0 and this is time t1, we know that when the coil is in the vertical position, then the EMF is 0. Okay, and when the coil is in the horizontal position, the EMF is maximum, and it might be positive or negative. Okay, so once we know that, so at time t0 it's going to be at 0, and at time t1 it's going to be at A, right? The maximum EMF that is being attained. Okay, then again when it is going to become vertical, it is going to be at B, and when it is going to become horizontal again, it's going to be C, and so on. So at time t1 the EMF would be maximum. So if we start from this and take it to be 0, so A is going to be the point where it is maximum at t1. Okay. Question number 32. What is the purpose of the sling ring commutator in an electric motor? Basically, the purpose of the split ring commutator is that the turning effect of the motor stays in the same direction at all times. So let's look at the option. To ensure that the magnetic field in the motor changes direction every half rotation, no. Split ring commutator is in a DC motor, so the direction of the current and that of the magnetic field is not going to change. To ensure that the magnetic field in the motor stays in the same direction at all time, it is there to ensure that the turning effect of the motor stays in the same direction at all time, not the magnetic field. See, to ensure that the turning effect on the motor changes direction every half rotation, no, this is wrong since it's a DC motor. And to ensure that the turning effect on the motor stays in the same direction at all times, yeah, this is correct. So D is our correct option. Number 33, a beta particle has less mass than an alpha particle, but the speed of the beta particle emitted during radioactive decay is approximately 20 times greater than the speed of an alpha particle. Okay, which statement correctly compares properties of these two particles? Okay. Alpha particles are less penetrating because they have less kinetic energy than the beta particles. Acha, alpha particles are less penetrating, but the penetrating power does not depend upon kinetic energy or this property. Okay, so this is not wrong. Alpha particles are more penetrating, alpha particles are less penetrating, so this statement is not correct as well. Alpha particles are less ionizing because they have more kinetic energy. Alpha particles are more ionizing. They are the least penetrating and the most ionizing. So they are not less ionizing. So this statement is also not correct. Alpha particles are more ionizing because they have more kinetic energy than the beta particles. Yes, this is correct. So option D is the correct option. Question number 34. Which observation provides evidence for the nuclear atom? Attraction of opposite charges, no. Emission of gamma rays during the decay of radioactive nuclei, no. Scattering of alpha particles by a thin metal foil, yes. This is the experiment that was done for the evidence of the nuclear atom. So C is going to be our correct option. Question number 35. Which effect on living things is not caused by ionizing radiations? Cancer is caused by ionizing radiation. Cell death is caused by ionizing radiation. Infections are something that are not caused by ionizing radiation. Mutation is also something that is caused by ionizing radiation. So C is correct. Question number 36. Isotope X is radioactive. Which statement about X must be correct? A nucleus of X is unstable. Yes, this is the correct option because the nucleus of radioactive particles are unstable as opposed to the ones that are not radioactive. So this is our correct option. And X emits alpha particles or beta particles or gamma radiations. This can be anything. So this is something that must be correct. All of these can happen, but this is something that is a must. So A is our correct option. Question number 37. An experiment is done to measure the radiation from a radioactive source. The source has a half-life of 10 minutes. The source is placed close to a detector that is connected to a counter as shown. The average background count rate is 20 counts per minute. At the start of the experiment, the count rate recorded by the counter is 1000 counts per minute. So what is the count rate after 10 minutes? Okay. So now what we need to do is that first thing is first, we have to get rid of the background count from the count rate recorded by the counter. Okay? So 1000 minus 20 counts per minute has to be done, and the answer that we get is 980. And now when 10 minutes pass and the first half-life is reached, so 980 divided by 2 is 490. 490 counts per minute is going to be the reading. Okay? And then when we've reached, because they've told us that what is going to be the count rate after 10 minutes, like after one half-life only. So when we've reached the value, we have to add in the background count rate again to the value, and this is going to give us 510 counts per minute. Okay? So C is going to be the correct option. This is how we solve this. First, we have to take out the background count from the reading. Then we have to go on with the half-lives, whatever time or half-lives they've provided us. And when we've reached our answer, we have to add back the background count rate and then reach our answer. Okay? So if you have any confusions in this, kindly go to the topic of half-life, and there you will have everything that you need to know about this process. Okay, question number 38. In which direction does the sun appear to move every day when viewed from the earth? So it is general knowledge that the sun appears from east and goes to the west. Okay, so A is going to be our correct option. Question number 39. A distant galaxy is moving away from the Milky Way at 44,100,000 meter per second. What is the approximate distance between the Milky Way and the distant galaxies? Okay. So in order to find the distance, we have a formula. Speed is equal to Hubble's constant into distance. And Hubble's constant is 2.2 into 10 raised to the power minus 18. So the speed that has been given is 44,100,000. Hubble's constant is 2.2 into 10 raised to the power minus 18, and the distance is going to be found out by dividing 44,100,000 by 2.2 into 10 raised to the power minus 18, and you will get an answer of 2.1 into 10 raised to the power 24 meters. So this is our correct option. Okay. Question number 40. The orbit of Mercury is closer to the Sun than the orbit of the Earth is to the Sun. So how do the values of gravitational field strength of the Sun near Mercury and the orbital speed of Mercury compare to those values of the Sun? Okay, now if Mercury is closer to the Sun, so its orbital speed is going to be more than that of the Earth, because Earth is farther away and there is Venus in between as well. So its orbital speed, the orbital speed of the Earth is going to be less than that of the Mercury, and obviously the Mercury is closer to the Sun. So the gravitational field strength of the Sun will be greater on Mercury as well. So gravitational field strength of the Sun near Mercury is going to be greater, and the orbital speed of the Mercury is going to be faster as well. So A is going to be our correct option. Okay, so we've reached the end of our paper 0625 May June to P23. I hope my video was helpful in understanding how to solve these questions. So take care of yourselves until the next time, and best of luck for your studies. And if you found anything helpful in the video, kindly like and subscribe the channel, and remember me in your prayers. Allah Hafiz till the next time.